Thermodynamics studies the relationships between various forms of energy. There are several laws that help us study those relationships, including the zeroth law, first law, second law, and third law. Welcome to our lectures and learning video on the first law of thermodynamics. If you're new to the channel, be sure to subscribe to see more videos on thermodynamics, nuclear power, and other fun learning stuff. If you enjoyed this video, be sure to give it a like. Let's dive in. There are many types of energies, including heat energy, chemical energy, mechanical energy, electrical energy, motion energy, elastic energy, and even gravitational energy. So what does that have to do with the first law? Well, the first law of thermodynamics states that for a given system, the total energy remains constant. You've likely heard it stated in simplified terms as, energy can be neither created nor destroyed. Another way to say it is that energy can be converted from one type to another on a given system without losing or gaining total system energy. This idea is called conservation of energy. A system conserves or retains all its original energy even if things in the system are changing. Take a ball on a high shelf, for example. Initially, the ball is at rest, but due to the mass of the ball and the force of gravity, the ball has potential energy above a reference zero point such as the floor. This potential energy, PE, can be shown as the mass of the ball times the force, due to gravity times the height of the ball above a reference zero. However, if we pull the shelf out from under the ball is no longer at rest and instead begins to move. The ball's potential energy is now being converted to kinetic energy. Kinetic energy, KE, can be shown as the mass of the ball times its velocity squared, divided by 2 times the gravitational constant. Once the ball hits the floor, its kinetic energy is again converted back to potential energy. It's the first law of thermodynamics that lets us evaluate the transfer of energy within that defined system. Other examples include converting the stored chemical energy of a battery into electrical energy in a circuit. Because energy isn't created or destroyed, we can evaluate the amount of energy in an electrical system and determine how much of any type of energy is at any specific point in the system. Even energy losses such as friction and heat are simply conversions of energy accounted for by the conservation of energy. Everywhere we look, for any defined system, the first law of thermodynamics allows us to study the amount and types of energies and how they are converted from one type to another. Be sure to leave your questions in the comments section, and thank you for watching our video.